Yeah.
Yeah, I think recording has started. Yeah.
Okay, let's keep it there, right? Instead of ending the recording and then starting again.
Yes, you later on you can just clip this part of this recording.
Okay.
Okay, so maybe it is just about time. So we can start with the formal introduction. So as I said, Professor Azam, he is a graduate of Kyung Hee University. He is currently at University of Nottingham in Malaysia, and he is an associate professor there. Previously, he was a senior research scientist at Carnegie Mellon University, Qatar. He also worked with Carleton University, Canada, and Ryerson University, Canada as a postdoc fellow. He completed his PhD computer engineering from Kyung Hee University, Korea in 2015. In addition to that, he has completed a course on data science with R from Harvard University, USA in 2017, and a course on Internet of Things from King's College London, UK in 2016. He has more than 100 publications, including patents. He is also a founding member of IEEE SIG Intelligent Internet Edge. For additional details, you can look at his website, which I have shared with all of the students. And also, other than that, he is a recipient of many other awards and many recognitions, which he has humbly not included in the biography, but I know it personally because I know him personally. So please welcome everyone, Professor Muhammad Azam, for his talk on the 5G tactile internet for industrial IoT.
Thank you so much for the generous introduction, Dr. Junaid. Thank you so much. And thanks everyone for joining in so far. And I think I should start the talk now, right? Or is there anything you want to
yes,
say
sure. Please start
before?
the talk.
Okay.
Yes,
So
you
let me
can
first
share your
these
slides now.
Yeah. Okay. Just let me know if you can see the slides.
Yes, the slides are on screen now.
Okay, that's great. Okay, the first thing is, or I should first, I think, minimize the thumbnails. Okay, first thing, it's on 5G tactile internet. We'll talk about the journey that we have been through in terms of web development, the evolution of web and all that stuff. And then we look at how we have come to the point where we are in a position to enable tactile internet and how 5G plays its role in enabling tactile internet and specific to the industrial IoT domain. That's the main theme of this talk. This would be the outline. We look at the web evolution, Web 1.0, Web 2.0, Web 3.0, and all that stuff. We look at how we moved on to the current IoT, Internet of Things era. And then we look at how IoT started evolving into industrial IoT, and then how we are now in a position to talk about tactile internet of the future. Even though today we do have tactile applications, but still we'll be looking at the future of tactile internet and how 5G and private 5G would enable that. We'll also look at that when you're talking about tactile internet, there must be quality of service as well as quality of experience that would play a very vital role in making tactile application user-friendly and user-acceptable. So we look at some aspects of quality of experience at the end of this talk. And I think just to clarify, just to let you know how to interpret this entire talk and how to understand the things that are on each slide, I would just say that we look at a broader perspective. We'll go through the evolution so that we have the historical background of whatever we have today. And then we'll gradually focus fine grain on one point, which would be our tactile internet and how tactile internet would be playing its role in the future and the QoE thing that I just mentioned. So there would be a historical background, the evolution, and then a focus on one point. And then we look at a broader horizon that we'll have at the end of the talk. When you look at the slides, there would be text, there would be illustrations, there would be images and figures. Try to map those illustrations and figures with the title and the content of the slide so that you better understand the information that is presented on each slide. Also, there would be occasionally side notes in green color like this. I hope the cursor is also visible because I have to use this cursor throughout the talk and I'll point out on different things. So these side notes are for any additional information. They are on some of the slides. And you don't have to necessarily read every single sentence on each slide. Just look at the blue highlighted text so that you quickly go through the concept and you can understand the things. During the talk, feel free to ask me questions or to initiate any discussion. You can unmute yourself at any time. You don't necessarily have to raise your hand, but if you like, you can do that. I'll try to keep an eye on the hand raise thing as well as the chat. So you can write your comments or your feedback or your questions in the chat as well. And always feel free to unmute yourself and ask questions. Interrupt me, nobody's about that, okay? And if you're more comfortable, you can ask questions at the end. So this would be the way this talk would be. We look at the web evolution. We look at Web 1.0, Web 2.0, and Web 3.0. How things transitioned, how new technologies came into our use, and what was the flow? Where was the overlap? Because it's not possible, you know this thing, you're also into the technology stuff, you know that no technology has a particular starting date or an ending date. There always is an overlap. Technology depends on, especially today's technologies, they depend on multiple technologies, integration of multiple technologies. And this is how we come up with new services, smart this and that, intelligent services. They're always, especially in the recent times, they are amalgam of multiple technologies. So we look at how the evolution has been. At what point did we realize that we need to improve something, and what is that something? We look at all these aspects. We also look at the beginning of the web. That in the beginning, Web 1.0 and all that stuff, we had syntactic web, and then we evolved into social web, which later on made us realize that we need the meaning of our social web, and hence we moved on towards semantic web. And then the Internet of Things, and then the Internet of Things itself evolved into Industrial Internet of Things, IoT. Then we'll reach the focus point of this talk, the tactile internet. We look at how 5G enables tactile internet, and if there is no 5G available, can we use private 5G to enable some of, not all, but some of the tactile internet use cases. We'll also look at QoE-based adaptive tactile internet. And through all this information, we'll be in a better position to look at this infinite horizon. Probably we'll have a better and broader horizon, and we'll be able to look at the future, which is 5G enabled tactile industrial IoT. So this is how the flow of this talk would be. Let's look at web evolution for the start. Okay, first of all, we had Web 1.0, mostly read-only stuff. We had static pages. We had online presence. The main focus at that time was to have an online presence, mostly for companies. There were some individuals having online presence, but the main focus was for companies. For example, Microsoft's website, Google's website, Kyung Hee's website, stuff like that. And mostly read-only. You cannot do anything else with the information you have because it's entirely static. That was the time of Web 1.0. And then we evolved with the time. We realized that that's not enough. We need to have something to write as well. We should have some web forms to input information so that we can process that information and make use of that information for some services. And hence we had read, write stuff. Most of the stuff was read, write. This was the evolution from Web 1.0 to Web 2.0. And then with the time we realized that, okay, we need some portability and personalization. And hence we had these two key aspects in Web 3.0. This was earlier 21st century 2000s and most of it after 2010 in the second decade of the 21st century. Portability with the advent of smartphones and personalization. So read only to read write and to portability and personalization. Now, if you look at these things, then you can probably envision that how basic technologies, the underlying technologies would have evolved. And what do we need in the future? In the beginning, the focus was company-based or individual-based. Individual-based does not mean that the focus was on the individual. The focus on the individual was in the case of Web 3.0, but individual presence was there. But then later on, when we evolved, we realized that this is not enough. That's just building up the information. We're not really using that information. Why not connect one information with the other information? Why not somehow have connected pages that one information is somehow connected to the other information? And that way we'll have an online community. Hence, the focus switched to community instead of a single company. And we had grouping. And then with the passage of time, we learned that within the community, we have to focus on every single individual so that we can make use of their information. Probably this would be a little bit confusing right now, but as we move on, I anticipate that you'll be able to understand this thing in a better way, that how this was community and then we got into the individual stuff again. This is basically the use of information from every single individual. While in this case, as we've seen before, that it's read only. So the company focus is just read only. There is no use of that information. We had home pages, companies' home pages. And then we had blogs and wikis, for example, Wikipedia. Wiki means anything editable that we can professionally edit and update the information. And then we realized that we'll look at this thing in the coming slides, that once we had better internet connectivity, the size of data also increased massively. And the most noteworthy change was multimedia, videos online. And hence we started having live streams. And in the recent times, we have waves, and now we have spaces, for example, Twitter spaces. In Web 1.0, the main focus was owning the content. Who is the owner of the content? While we realized that sharing the content should be more important so that we disseminate the information much faster. But then we realized that sharing the information might be consuming us a lot of bandwidth as well as storage capacity. Why not make sense of that information? To make sense of that information, we have to consolidate the content and understand the meaning behind each content, grouping of the content. Okay, and we had web forms versus we had web applications. Okay, now in the beginning, we had static stuff. And then we moved towards dynamicity, web applications. I have an application that is web-based. Now I can use that application instead of having that application on my computer. And once we had the context and the semantics of those web applications, we were able to realize smart applications that we are using since last few years. Okay. We had directories, and once we moved towards the community stuff and the sharing stuff, we started tagging people, tag on Facebook or tag somewhere else. So this way we could somehow hook people and tell them to look into some information. That was the way of connectivity or interactivity. But then we realized that this tagging might not be enough. We need to know the user behavior, how a user interacts with something, liking, saving something, sharing something, commenting, stuff like that. And this part, this behavioral advertising is also related to this thing, user behavior. We had page views, and then we used to pay per click, paying per click. While in the recent times, we are paying per user engagement. How many views on your YouTube video? How many people commented on your YouTube video? How many people click on the bell icon? This is user engagement, how much the user is engaged with you. Banner advertising versus interactive advertising, because you had the community and sharing stuff. You can interact with people and advertise through interactivity. While in the recent times, advertise based on the behavior of people. How many people have liked your video? Based on that, we'll advertise things, because now we know your reach. Now we know your impact. The noteworthy content was Britannica Online or Project Gutenberg. The noteworthy content in this case, Web 2.0, was Wikipedia. And in this case, we have several applications that are based on the meaning of the content, which we generally call the semantic web. The tools that we used in the case of Web 1.0, HTML, in the case of Web 2.0, XML and RSS, in the case of Web 3.0, RDF, RDFS, and OWL. So ontology has been the main focus in the recent times. Ontology, developing ontologies, and then based on those ontologies, we are able to categorize things and hence group them, plus create context out of that categorization. Let us look at this illustration, the smart extended web. If you look at the degree of social connectivity at the bottom, x-axis, while the degree of information connectivity on the y-axis. Web 1.0 had the minimum degree of social connectivity as well as information connectivity. You can also call it semantics. Information connectivity is also based on semantics. So this thing could be your semantics, the degree of semantics. Minimum in this case. The degree of connectivity is maximum so far in this case, Web 2.0. While Web 3.0 has relatively minimized social connectivity, but quite high information connectivity. We have a lot of information reaching to us every day through social media and all other stuff, through the people that we connect to. So this is the hallmark of Web 3.0. But if we are moving to a much better web-based, smarter world, then the metadata would matter much more to us. And we should be able to connect intelligence. We are connecting knowledge right now. We have to build intelligence out of that knowledge. And once we're able to do that, we'll be able to have the highest so far degree of connectivity, information connectivity, or semantics, as well as the highest degree of social connectivity. This would be your Web 4.0, Web 5.0 in the later future, and so on. So we are today in the semantic web arena. This is Web 3.0, and we are talking about Web X.0, 4.0, 5.0, etc. So keep your focus on this thing, because you are the one who is going to build the future. Let's take a deeper look at each type of web throughout this web 1.0, 2.0, and 3.0. The very first one was syntactic web. Remember one thing, please, that as I mentioned before, that these dates do not mean that there was a particular start in this year and a particular end in this year. But this time period was throughout these slides, wherever I mentioned a timeline, then in most of the cases, probably not always, but in most of the cases, the timeline represent only the main focus of that technology. The technology starts developing before that and also merges into the next one. There is an overlap always. It doesn't mean that in 2000, syntactic web ended, or in 1990, syntactic web strictly started, and before that, there was nothing like that. The main concept of syntactic web is literal comparison. Just match the textual content of the resource. And if you look at an example of searching, if you search something, for example, if you search hotel, it would strictly match the text. It would strictly match the word hotel in double quotes, and the crawler would crawl through the websites to look for this particular term. And if there is any website having these terms that are related to hotel, for example, accommodation, guest house, inn, these terms won't be searched. They won't be matched. Okay, so that was the main problem. Why? Because we did not have the semantics. We were strictly Boolean matching the things. Computers used to present the content, which is much easier. Just fetch the content and show it to the user. That's it. While the users would do the interpretation of that content and linking of that content, one content with the other one. So that was the manual thing. Now, interpretation and linking depends on every user's prior knowledge, every user's state of mind, and every user's context, which means that the interpretation and linking could have several mistakes. What were the main challenges in the case of syntactic web? The very first thing is you cannot search any complex queries. For example, locating information in the data repositories, any travel inquiries, prices of goods and services. That's not possible. You can just look at the information that is present. You have to search the information exactly in the same way as it is available up there on the website, wherever. And in most of the cases, you do not know that what would be the term used for any particular information. Also, we were not able to find web services or delegate any tasks to web agents. We have some web agents. This is one web agent accessible through the web and available to do some tasks, but it's really hard to find that web agent. Why? Because I'm not really sure what's the name of the web agent, or if I'm trying to search the web agent using my terms and those terms are not really matching with that agent, then it's really difficult to find those agents. An example would be online booking with some additional checks or attributes. What was the noteworthy content in the era of syntactic web? Personal websites, Project Gutenberg. Alta Vista was the well-known search engine at that time until I think late 1997 or 98, when Google was introduced and Google took over the popularity from Alta Vista. I think the Korean version of Tao was also available at that time, at the end of 90s, I think. We also had address books available online. These were the main things that were there. And then after 2000, in 2000s, we realized that the social connectivity would be more important. That's not enough. These are just static web pages. Some static kind of information, not enough for us to do additional things, not enough for us to create some applications, or not enough to create the interest for our users. So why not have some social connectivity? In the late 2000s, 2000, I would say 5, 6, 7, 5 was the time when I think YouTube was introduced, I guess, and then later on we had the other social networking websites. The main focus was on social connectivity. We had Orkut, Twitter, Facebook introduced. And that was the time when internet connectivity became massively better. We had broadband more widely available. That was revolutionizing. That was the first major change that happened in the web technologies. That was the time, after 2005 or so. And there's always a two-way connectivity or interdependence. Two-way between the infrastructure and the user's usage. My demand would increase if my infrastructure is better. And once my demand changes, or my demand, or I become more demanding, my infrastructure would be would require to get better as well. So it's a two-way thing. They are both interdependent and intertwined. And that was the time, the most complex time in the 2000s, especially after 2005 or so. So we had better internet connectivity, and hence we realized that now we can have videos online. We couldn't have videos online before. We used to have illustrative stuff, we used to have images, we used to have text, obviously, but it was difficult to disseminate video content. But now, once we had better internet connectivity, we started having video content, multimedia content with better quality online. And hence we also had streaming as well. But once we had this stuff, we realized that this is consuming a lot of storage space to us. Not easy to have that amount of storage space for the fast increasing video content. What should we do? That's a problem. Foreseeing the future, we realized that this would be really difficult to handle. And hence the technology of virtualization came into place. And through virtualization, we realized that now we can have cloud computing. We used to have virtual machines, but then we globalized our virtual machines, and we had cloud computing. Cloud services started emerging at that time. So as you can see that you hear about these terms, cloud computing, streaming, and all that stuff. And if you look at the evolution of these things, you would realize that how the interconnectivity is or has been, and how these things are going to shape in the future. If we know this thing, then we'll be able to better prepare ourselves for the future and have more meaningful applications rather than just desiring something and then trying to fulfill that desire. Instead of that, we should focus on what exactly do we need. Now, there was a problem. There was a problem. The problem was that we were more into social connectivity. We were more into multimedia. We were more into disseminating high quality and large sized data online. The problem was fetching the correct information. The problem was that are we really in a position to understand each available content that we have? Because we were mainly focused on the literal comparisons, textual content. So the social stuff was good, but we realized that we probably have jumped to a point where our desires were changed and evolved, but the infrastructure was not really evolved at that time. And then we backtracked. We came back and we realized that we should have better meaning of the content that we have, and hence the semantic element was introduced. It started in 2005 onwards, even though semantic web that we look at in a bit was more prominent from 2010 onwards. But still the semantic, as I mentioned earlier, that no technology has a fixed starting date and ending date. There is almost always an overlap. So the semantic element was from 2005, and the main focus was from 2010 onwards till 2020, and even until today. What was the main challenge? Yes, semantics were really weakly connected. Hence, not all the information was able to be retrieved. The noteworthy content at that time was dynamic websites, that's the first thing, then content management, wikis, for example, Wikipedia, social networking, and streaming. Then we moved on towards semantic web. 2010 till today mainly took off from 2005 onwards. Main focus was semantic comparison instead of literal or textual comparison. Now we already had this social element. Okay, we already had the social element. We were just trying to improve the social element by having the meaning. The main aspect or attribute of semantic web has been ontology. How entities are grouped into categories. What categories? How do we define the categories? And then how do we group elements based on each category we have? Semantic understanding and the conceptual framework of knowledge. We did not have the conceptual framework of the knowledge we had. We had a lot of knowledge, or I should say we had a lot of information online through better internet connectivity, through streaming, through so much of this sharing of content at that time. And then obviously virtualization and cloud computing. We were able to make semantic searches and semantic social networks. So the social networks of the earlier times were really weakly connected, or the conceptual framework of knowledge that is created based on this social interaction was really weak. But that got improved with the passage of time in 2010, after 2010 onwards. And once we had the grouping and categorization, we were able to, and once we were also able to do the conceptual framework of knowledge, we were able to have better interoperability of the content we had available online. That was the main thing. And I hope you can now understand the evolution and how each element, each factor became important. And obviously you can pick any of these factors and then fine-grain that factor and focus on that for your research or whatever you're doing. What was the main challenge? Tons of information, too much information now. Better connectivity, obviously, we already had social connectivity. Now we can even make more sense out of the things we had, hence tons of information. But we were not really able to make sense of that information. That's too much for us. Yes, we can do basic categorization. We can do the basic conceptual framework of the knowledge, but still that's too much for us. Can we really connect agents, any web systems or subsystems, to have more meaningful and intelligent communication as well as service provisioning? Can we do that? Not really. The noteworthy content at that time was third party services. So now we were more kind of online. We were getting online. This is available online. That is available online. Place an order online. Get a taxi online. Shared economy. Airbnb or Uber Eats kind of stuff. Third-party services and shared economy became really important at that time. And then we got into the point where we realized that with the passage of time, we are able to categorize things and try to make sense out of the information we have. Why not have connectivity of as many things as possible? We have intermediary devices. We have RFID, we have QR code, we have tags, we have sensors, we have GPS, we have many other things. And since we already had smartphones, we realized that now we can connect literally anything with the internet. And since we are somehow able to do that, we can create services out of that connectivity. Now, instead of merely focusing on the people and a few agents, we were now able to connect things, anything, any object, any device. This could be a dumb object. But remember that Internet of Things, or IoT for short, does not mean that you can just connect anything. It means you can connect things and create services out of that connectivity. For example, we can connect vehicles through GPS sensor. The GPS sensor can be built into the vehicle or can be through a smartphone of the driver driving the vehicle. Through that, we can connect the entire vehicle to the internet. But is that enough? No, it's not. If you're talking about Internet of Things, we have to create service out of that. Maybe have a middleware entity, maybe have some processing, maybe have some cloud, and then make use of that information through semantics and grouping. Focus more on the information because we're not really focusing on the connectivity of agents. Focus more on each connectivity now. Because we had tons of information, but we were not really able to make sense of it. Why not focus on each information and try to make sense of it, and hence have services that are available online through the connectivity of things. For example, you have a navigation app, which is a service that you create out of the connectivity of vehicles which are not able to directly connect. Okay, so that was the main concept. Thing could be anything: device, smartphone, computer, sensor, machine, appliance, object, camera, access card, vehicle, tree, living beings, or anything on Earth, or even beyond Earth. What were the main challenges? The main challenges were service or device discovery. Okay, now, okay, got it. The thing is that before we were not really able to make sense of the information. If we try to focus on each information, we can probably make sense of it. But then the problem is, are we really able to discover the devices that we have on the ground with the cloud, for the cloud, so that we could create services out of it? Can we do that? Also, since we had things connected to the internet, and obviously there is a distance being involved between the connectivity. Things on the ground versus the cloud that is accessible through public internet. then obviously there is a latency problem for some applications, not all, but some. Obviously, privacy problem, public internet, security problem, public internet, and then a lot of information again going on through the public network. So load balancing. Who is going to process the data? Somewhere in the middle. How do we balance the load? Yeah, that's the main challenge. There were different variants of IoT. Once IoT was evolved or introduced, then we had different versions of IoT. We had Internet of Everything. This means you have IoT plus the element of people. If you connect people with IoT, you have services which are IoT based plus really dependent on people, crowdsourcing and crowd sensing kind of services. Then this is Internet of Everything, IoE. But if you strictly focus on the people, the aspect of the people, who they are, their usage behavior, their mobility pattern, stuff like that, then that's Internet of People. And if you involve the social aspect into the IoT, for example, through social networking, can we create services out of social networking? A service based on an IoT service based on social networking, for example. I'm getting some information through Facebook feeds or a Twitter feed that something specific is trending in a particular country based on a global event. Can I create a social Internet of Things out of that? Can I somehow influence the thinking of the people and stuff like that? So this is the social IoT. And then we have Internet of Me, IOM. The main focus of IOM is bringing your brain, your mind online. The mood changes, the mental health, and instructions based on the thoughts. So I have sensors, EEG sensors on my head, and based on that, I can perform different tasks online through the internet. That's IOM. The main focus should be on the mind, not the entire body. If it's on the entire person, then this is Internet of People. And obviously, if the focus is on the industrial domain, then that's industrial IoT. If we talk about the industries, let's bring the industries to the IoT domain and somehow control them and run the industries through IoT processes. That would be IIoT. If you have drones connected to the internet and you manipulate them, drone delivery, drone-based emergency management, stuff like that, then that would be your Internet of Drones or IoT. And we generalize the variants of IoT as IOX, IO anything. Do you want to know the history of IoT? I mentioned in the beginning that no technology has a specific start date, but technologies usually evolved over the time, and there were reasons, there were events in the past that led to a technology after even maybe 30 years. So something happened 30 years back, led to a technology 30 years after. This is kind of surprising, right? That something happened 30 years back and we were not really able to envision the technology. Why? Let's go back. Let us look at this thing. We did not really realize that we need IoT. We were into this thing. But when we were into this thing, there was already an IoT application running in 1982. You see, there's always been a gap between the user's expectation and the technology available. And because of that gap, at times we're not really able to understand what we really need So one aspect is, what do I actually need? And the other aspect is, do I have the infrastructure for that to fulfill the need? And through this talk, we are trying to kind of understand how the evolution has been, and probably prepare ourselves better for the future, so that in the future we only focus on what do we actually need, and then we make changes in our lives based on those needs. So let me give you a brief history of IoT. In 1982 at Carnegie Mellon University, in the School of Computer Science, there was a vending machine. There was a Coke vending machine on the 3rd floor. They were not really common at that time. The computer scientists like yourselves, the engineers like yourselves, the scientists like yourselves, they used to really crave for the Coke, especially if you're a programmer. Then it happens really often that at odd times you crave for such kind of things, caffeine or whatever that is. So they used to have, go to the 3rd floor to get a Coke can, but at times there was no can available, because the machines were not really widespread at that time, and the demand was high. A lot of people were looking for Coke cans, not cocaine, Coke cans. Okay, so also there was another problem. The problem was that at times the Coke cans were replaced recently, and hence they were warm. So what the computer scientists in the School of Computer Science at Carnegie Mellon University did, they used their school's computer server, which was known as finger server. And they also installed micro switches into the vending machine to see if there is any Coke can placed there or not, as well as at what time the Coke can was placed there. And hence you would know, you would be able to tell if the Coke can is chilled or not. Instead of going to the 3rd floor, they created a program that was accessible through ARPANET, which eventually evolved into today's internet. So that was the solution to this problem. They had a problem and they had this solution for that, which later on, after 30 years or so, we realized that, okay, we had an IoT application 30 years back. And this came out of the laziness of the programmers there. So it's really, sometimes it's really good to be, lazy but smart. If they were not lazy and they lived with what they had, go to the 3rd floor and look for the Coke can, there wouldn't have been any internet connected, this kind of vending machine at that time. So we've looked at most of the stuff related to the web evolution. Let's look at this figure. Let's look at the socialization at the bottom and the semantics on the y-axis. We had PCs in the beginning, we had internet, then we had desktops and all that stuff. We had some web technologies. We had web 1.0. Once we had the World Wide Web. Then we started having multimedia and the socialization aspect. Now, this was the point when there was a drastic change. If you look at this arrow, a branching arrow from this regular arrow, look at this evolution. With this evolution, there was a parallel evolution going on. This parallel evolution, this one, this branching arrow, was more focused on socialization. This socialization plus semantics was predictable, straight line. but there was a drastic change at some point here. Okay, the main focus was on the social connectivity, and then since we had the mobile communication, the personalization stuff got more involved into the web technologies, and obviously better internet connectivity. While in parallel, the evolution was in the same progression. We had the semantic technologies, and now we are into Web 4.0, where we are talking about more of the context rather than just the semantics. We look at that thing here. The producer producing more and more information if we have this kind of applications. If we have learning management systems, if we have personal learning environments, if we have adaptive smart systems or intelligent systems, then more and more information would be produced, while more and more information would be consumed if we have intelligent agents and these online technologies that we can use to make sense of the information we have, the evolving information. In the beginning, we had the syntactic web, then we got into semantic web, which we still use today. But over the time, we have realized recently that the meaning, the semantics won't be enough, and we should be looking at the context awareness. If we have the context awareness plus the meaning, then the context plus meaning would give us intelligence. And better intelligent systems available online on the web would become possible. So the future is a combination of semantic web plus pragmatic web. Okay. Let us look at industrial IoT. So we have looked at the web evolution. We have seen that how we started and how we got to IoT. Then IoT got refined. IoT got more and more meaningful. And IoT got into industrial IoT, industrial domain. Okay. Have you ever heard of Industry 4.0? Have you ever heard of Cyber Physical System, CPS? And have you ever heard of Smart Factory? Can you distinguish among them? Can you tell what's the difference between industrial IoT versus Industry 4.0, CPS and Smart Factory? Are they the same things, synonyms, or what? Let us demystify this thing first, just in case you do not know, if there is any new student or someone who's not really familiar with these domains. When we talk about IoT, that's, is it a question? Okay, when we talk about IoT, we're talking about connecting anything with the internet. But when we talk about industrial IoT, it means we are connecting the industrial things with the IoT. And when we talk about manufacturing industry in specific, we are only talking about the manufacturing industry, not the other industries. Industries have different types. There is food industry. And in some countries, education is also considered as an industry, not just a sector, or even healthcare is considered as an industry in some countries because they earn out of that. If you're talking about the manufacturing industry in specific, then that's your Industry 4.0. So IIoT is more generic, and Industry 4.0 is specific to manufacturing industry. We'll look into these things more in the coming slides. On the other hand, if you're talking about the embedded systems plus the cyber world, you have people connected to those embedded systems. You have other systems, subsystems connected to those embedded systems. Or you have and overall connectivity within your organization of web applications, then that's your cyber world. And if it is specific to embedded systems, then that's your cyber physical system. This means that CPS is one small part of IIoT. And when it comes to smart factory, then it's highly digitalized. Industrial IoT means that my industry should be available over the internet for some services, not just the connectivity, but there should be some services. I should be able to perform at least some tasks over the internet for my industry or within my industry. For example, automating the processing line or production line, automating the packaging, or automating the fault tolerance. I'll talk about this thing in the coming slides. There is one slide where we talk about different sides of one industry, and that would be the point where we should, I think, talk about how we should connect different sites. So that's the concept of IIoT, but in the case of smart factory, it's highly digitalized and highly connected environment where things are not just automatic, but they also take their output as their own input. And based on that, through adaptive machine learning, they're able to understand the entire process and improve it evolutionarily, which is self-optimization. So your smart factory can be part of your IIoT, but it has to be really digitalized. Most of the tasks should be digital and automatic. Just in case you're still not really sure about the difference between smart factory or any other factory, then a pro tip would be to look at this figure. If you see wireless signals more than the smoke coming out, just realize that this is your smart factory. Okay, that's the easiest way to understand this thing. Okay, yeah, this is your cyber physical system. Okay, so the next thing is this. You want to look at, just in case you're interested in cyber physical systems, go through this paper and look at this thing with more details. This part is discussed with much more details over there. And I reckon you can do your PhD in any of the layers presented here, any one of the layers. For example, how CPS nodes are connected. What kind of nodes could be part of a CPS? This is an embedded system. I have a robot. I have an automatic assembly line or packaging line. I have an actuator. I have embedded sensors or systems. How all these things could be connected? Can we interoperate them? Can we optimize their energy consumption? Can we optimize their data generation? And for what particular scenario and for what particular thing or device should we have what kind of connectivity? Wi-Fi, Wi-Fi 6, light fidelity Wi-Fi, much cheaper and faster, I think, but the problem is line of sight. Let us look at the scenario and then based on that decide which one do we need. Cost optimizing plus better data communication. Or 5G. Is 5G going to work well indoors because of smaller waves, the millimeter waves? Or do I have actuators or do I have devices that are mobile? And probably I would need 5G so that they are always connected, whether they are indoors or outdoors, some robots or something. So you can focus on this layer alone as well. And based on that, what kind of middleware should I have? And what should be the responsibility of this middleware? Monitoring the energy consumption, optimizing something, any other way of green energy, or maybe flow control, maybe have some SDN based communication. Do I need a micro data center fog computing node or a multi-access edge computing? Then how do I connect that with cyber system, some web applications, some other web agents, or a user? Can I create cognition out of it? Machine learning based on my cyber connectivity and CPS nodes. How about human-machine interface? There would be scenarios in the future where one machine would be using another machine. For example, a robot using another machine. So this won't necessarily be human-machine interface. This might be a machine-machine interface. Are you making your robot intelligent enough to operate a machine? Or the interface of that machine is good enough for a robot to handle? You can do your PhD in this domain, or maybe apply for a grant. Configure that. Configuration means how actions would be performed, how faults would be detected. Based on a fault, what reaction should be performed? What kind of data should be sent over for analysis? How do you create business out of all this? Make money. Let's look at this image to understand the overall concept of IoT so that we don't have any ambiguity in our minds. This is our IoT. Everything is within the boundaries, whether they are smart homes or any traffic management thing, any industrial IoT. If you're talking about the industrial domain, then that's your industrial IoT within your IoT boundary. And if you're strictly talking about manufacturing, electronics manufacturing, textile manufacturing, food manufacturing, automobiles, that's your industry 4.0. Within your IIoT boundary, you have factory. This could be any regular IIoT factory, or this could be your smart factory if it's highly digitalized. Plus, you don't have the smoke coming out, but the wireless signals coming out. And by the way, intelligent transportation systems, even though it's part of transportation, but this could be, not necessarily, but in many scenarios or in the coming scenarios in the future, most of the ITS applications would be within the domain of IoT. Components of IIoT, I think this is important to know because now we are gradually focusing on one point. Now, probably you would have realized that, okay, we started with the web technologies and then we realized that how we evolved into IoT and then we got into one part of IoT, not smart healthcare, not smart cities, but the industrial part. Then probably we should know more about the industrial IoT because that's the focus of our today's talk. The first thing that is important within IIoT, and remember that each green component, this green color component, could be your PhD topic, or this could be a project that you can apply for, a proposal that you can apply for funding. Localization of wireless sensor networks and wireless sensor actuator networks. Your IIoT won't be complete without sensor networks and actuator networks. How do you localize them? Localization means within my industrial domain, within my industrial boundary, how many sensors do I have? And how many sensor networks do I have? Am I connecting my sensors with other sensors unnecessarily? Do I have a lot of sensor networks or do I have a lot few sensor networks? How do I understand these things? I would be able to do that through localization. I should be able to monitor each one of my sensor as well as actuator. This is my localization. And obviously, if you want to know more about this thing, I've given a reference at the end. You can go over the paper that talks in detail about each one of these components. But for today, we are just briefly going through this stuff. So, okay, I've got the point that I should be able to group my sensors in a more dynamic way. Maybe 5 or 6 sensors in one group as one sensor network at one point, and at another point or in another scenario, I break down the sensor network and create another one with some other sensors involved. This way, I can make use of more and more information, and my industrial domain would be much more digitalized or automated. And I'll be able to make sense of the information coming out of my industrial domain. How can I do that? I can do that through a middleware entity, because if I keep on sending the entire information to a cloud or to a server accessible over the public internet, that's risky. Number one, too much information going outside to the public network, consuming the bandwidth. Number two, my industrial sensitive data is prone to attacks. I don't want to do that. Most of the whatever possible local processing should be through a middleware on site within my industrial domain. I have heterogeneous sensors. How should I interoperate them? It's not always possible to have sensors from the same vendor. I have to look at the cost as well and the underlying technology as well. I have sensors for monitoring environment, reading temperature, gauging pressure, proximity, location, smoke, humidity, and everything. And at times I would be looking for virtual sensors. Okay. The next important thing would be controlling and managing my devices, including cyber physical system. I have agents or cyber nodes available online, and they are machines interfaced with applications, and they have internet access. That's even more risky. Machines interface with other applications. Again, there would be a possibility of machine-to-machine communication. Is that intelligent enough? What is the risk factor? And I'm having remote access of my applications. And I'm controlling my embedded system and devices over the internet. Then there should be flexibility of services. I should be able to do most of the things online. If I can only monitor things online, but for taking an action, I have to be on the ground, on the site, then that's not the real automation I need. Which means that controlling and managing my CPS is not that simple. And for flexible services, I have to focus on this part. And again, I would need a middleware entity that should be able to do local processing. A lot of data would be generated. Can I create tailored services? Yes, only if I make the right use of that data through data analytics. So these are my tailored data analytics based on my particular use case, my particular industry, and my particular context. What do I manufacture? In which country? Is it a rural area or what? Do I have a faster communication, or I'm still relying on any older technology? It's not possible for me to always have physical sensors. That's really costly. For example, a sensor sensing temperature of any product before a raw material before the production, then the product during the production, and the product when it's produced finally. Let's suppose that I have to monitor the temperature during these 3 phases. Having 3 different physical sensors would be costly. A cost-effective solution would be to have virtual sensors, virtualize the sensor through software, and change the threshold, change the way the sensor is manipulating the information, the temperature. And we can do that through virtual sensing and virtual sensor networking. And again, this is possible through a middleware entity. For virtualization, I need cloud-like resources. I cannot bring the cloud down to my industry, but I can have a cloud-like middleware such as a fog node. Web of Things. Okay, we have looked at Internet of Things. We have looked at IoT. What is this Web of Things now? If you have services available on the web, then those services are known as Web of Things. If you have things connected over the internet, that's just IoT. You create service out of that thing. I have multiple things, I have multiple sensors, and I create a service out of those sensors. For example, within a city, I have multiple sensors, and I create the temperature. I create a service that gives me the temperature of different locations of that city, Seoul city, Suwon city. What about having similar multiple applications that are available on the web and connect them? If I connect those applications, not the things, but the applications, then that is known as Web of Things, which is a refinement of the traditional IoT. Okay, I have sensor robots, devices, and they're integrated to third-party web services. And I need to do that for my industry. Maybe my industry would be giving information to another industry, and I'm getting refined data from them. Okay, 80 minutes passed. Okay. So it's boring. It's getting boring. Okay.
It's not boring at all. I was just sensing that. Yeah.
Okay.
So
I'll try to wind up faster now. Okay. So I think you've got the idea. The people who are listening, they've got the idea. We have talked about the middleware a lot throughout this discussion, throughout these components. Do you want to look at different middleware entities? What kind of middleware do we need for a particular industry? Is it a mobile industry on the go? For example, transportation industry, cargo industry, taxi, public transport, anything else? Or a static one? Embedded systems, or highly mobile systems, or highly data consuming systems? Robots, actuators, or what? Based on that, you can decide, now this is my edge domain. This is my edge layer, the edge end user devices. Then I'll have small scale intermediary nodes that work as middleware entities, known as MIST nodes. Then I can have a fog node, smart gateway, micro data center, cloudlet. Or I can have the traditional cloud. Okay, do you want to look at these different middleware entities and how task offloading is performed? Then please look at this paper. And also, if you want to look at how fog would be used for the industrial IoT domain. And you want to look at different use cases, because those use cases are not discussed in this talk, because we want to talk about other things, tactile and all that stuff. We want to fine grain into the QoE part rather than the use cases. Then you can look at different use cases of fog-enabled IIoT, as well as research challenges. and go to this paper and get more details. Let's have a quote break and probably water break, or in Korean, mul break. Hana mul juseyo. In the meantime, if you have any question, please feel free to ask. If you have any feedback,
So I have a question. I'm not too familiar with the distinction between the cloud, fog, mist, and edge. And I'm not even sure if there is a clear distinct boundary between these four categorizations. So can you just briefly explain that in which scenario we will consider that this is the edge or mist or fog or cloud?
okay, if you look at the research work or research works done within this domain, then you'll see that some academics, they use the term edge and fog interchangeably. That's confusing, right? If we look at a broader perspective, and if we look at the literature we have available, then we can create understanding and boundary between these two things, as well as among the other technologies. So in brief, edge is your end user device. For example, your smartphone is your end user device. That's your edge device. Tablet is your edge device. Laptop or computer is your edge device. Any other device that is at the user premise for direct access of the user, Amazon's smart home device or anything else, that's your edge device. My vehicle is my edge device. Ambulance is edge device. Cargo vehicle, anything else is my edge device. And if I have some small scale local processing, then I'll use a better version of a router. Or for vehicles, I'll use roadside units. They would be my missed middleware. Anything that assists the edge device, but not really able to do large scale processing, for example, deep learning. I cannot have large scale computers or servers installed alongside the road, right? I can have small servers. I can have Raspberry Pi, Arduino, stuff like that, maybe attached to a traffic light and doing some extra processing. That's my missed. If I have a group of servers, a micro data center, let's say 20 servers or so, that's my micro data center. And if I have the connectivity with the telecom industry, then my typical micro data center or fog computing might not be the best choice for every scenario. In that case, I should have a cloudlet. So depending on your scenario, you choose your middleware entity. If you're talking about smart traffic lights, then you'll probably have some missed servers, Arduino, Raspberry Pis. By the way, you can still have multiple Raspberry Pis to create one micro data center. That's also possible. But it depends that what eventually is your goal, or what kind of data you're receiving, or what's the frequency of that data, plus the size of that data, and the service being created out of that data. It depends on that thing. The micro data center would be, in most of the cases, a few in a metropolitan area. Have you understood the difference between these three layers?
Yes.
Okay, all these three layers are localized. They are localized. Their reach is within a certain domain. For example, within user premise or within my university campus, or within my metropolitan area network, within my city. Okay, they're not globalized. If they're globalized and they have practically unlimited resources. If you look at these three layers, this one, and this one, they have practically limited resources. But if you have practically unlimited resources, I cannot exhaust the resources. That's one point. Second point, global connectivity, globalization, no localization. Then that is your cloud. So the difference between cloud or any of these three middleware entities would be that cloud is always globalized. You can access it from anywhere in the world over the internet. I cannot access this thing from anywhere in the world.
Right, makes sense. Thank you very much.
So that's the main thing. Globalization plus the resource pool. The resource pool should be practically infinite. And practically infinite means that whatever they have, I cannot exhaust that. I cannot have this 1 million virtual CPUs. Obviously, I don't need that. So the next thing is tactile internet. Now okay, so we looked at the IoT thing, and before that we had the evolution. Then we reached to the point where IoT was our focus, and then we got into IoT and looked at the industrial part of IoT. Now let's go into the tactile internet part, that the future is tactile internet. Today we are talking about IoT, tomorrow we'll be talking about tactile internet. But remember that already we do have tactile applications, but they are very few. And also most of the tactile applications would be possible through 5G. Hence, we have to see this thing as a future technology, because 5G right now is not widely available. So let us look at this thing. This is the future advancement of IoT. Tactile means communication of haptics. What is haptics? Haptic, in its most fine-grained form, means touch, sending your touch signals online. So far we were talking about users' interaction in the perspective of text, audio, and video. These were the three major things that a user would do in the case of interactivity in social web or semantic web or whatever it is, even in IoT. I'm not sending my touch, I'm just sending my voice, I'm sending my video, or I'm sending my keyboard typed or mouse or peripheral input data. But if I have to send my touch signals over the internet, as well as probably my senses, sense of maybe smell, sense of taste, over the internet, then that's my tactile internet. In the late 2000s, there was some emerging applications of tactile internet. As I mentioned in the beginning, that no technology has a specific started, but there is always an overlap. So this thing started at that time, but the infrastructure was not there, and there were other reasons, for example, privacy reasons and stuff like that. So it's still it is taking some time to have more meaningful applications. Now, if you send touch over the internet, then you need to see the reaction at the receiving end, because I'm trying to remotely manage something, manage a device, or manage a physical entity. Then I need near real-time control. Through touch, I would be able to do remote surgeries. Okay. And I need to do the navigation of objects remotely. So better internet connectivity is more important, so that it's seamless. Whatever I do from here, should be visible at the same time at the receiving end. How is it possible? In today's internet, that's not possible. I can use my tactile internet for healthcare, like remote surgery, remote monitoring, or whatever, manufacturing, operating machines remotely, mining. That's really important. Remotely operate a machine so that you don't have any human workers over there, so that if any disaster happens or any hazardous material erupts or hazardous gas leakage, then no harm to human beings should happen. Remote education. Does that make sense to you guys? Yes or no? Autonomous driving. So what were the main challenges? The delay. Haptics give us visual feedback. Hence, quality of service becomes more important. But we have been hearing this thing since, I don't know since when. Even in the case of 4G, even in the case of 3G, we were always looking at QoS. Probably that's not enough in the case of tactile internet. Quality of service just means that probably improving the latency and stuff like that. But the thing is that in the case of tactile internet, the communication is different. Now the communication is not based on multimedia. It's based on touch and the reaction of that touch. It's based on remote controlling. Then my experience matters much more than anything else. Am I getting the same experience? Is this tactile application good enough for me, or should I be on the ground to do things manually? Quality of experience or my satisfaction becomes much more important, and hence we need much better and faster communication. How do we get that? Through 5G. Yes, 5G is already available, but it's not available in its promised way, or it's not also available everywhere right now. It will take some time. Usually, historically speaking, it takes every mobile communication technology 10 years, a decade to completely roll out, and still I don't think that it's get to the desired spread. Anyhow, 5G promises depends on how you're using the antennas or what technology are you using, because you have a range of millimeter waves. So which range are you in? The direction of your antennas, the deployment of the infrastructure. If you look at the 5G service providers in the US, you will see that there is a drastic difference. Some of them in very particular, some few areas are giving you really high data rates, while the others are giving you just above 4G data rates. So it will take time, you know. But eventually 5G has the promise and capability to underpin tactile internet applications. And some use cases of tactile internet would incur more distance than the promised usual delay of 1 millisecond in the case of tactile internet. When we talk about tactile internet, we usually see that the recommended delay should be within 1 millisecond. Now, this thing depends entirely on the distance. Okay? I cannot have 1 millisecond delay from one end of the world to the other end. This means that my tactile application would be dependent on the distance as well. And some of the applications would be delay tolerant. I can tolerate some delay. So maybe 5G would be good enough for some distant applications. While those applications that require less than 1 millisecond delay should be confined to the distance that allows this delay. And again, the middleware part becomes really important, because now I have to do a lot of local processing to send the signals and to receive the interpreted or the reactionary data. Hence, fog and edge computing becomes even more important. Take a look at this thing. Sending the touch from here over the telecom core, 5G. You do the local processing, management of subsystems, SCN controller, software-defined networks, flow for each kind of application. You have local storage, security measures, because it's important, virtual servers for virtual sensors, stuff like that, data analytics, everything locally. 2, have faster communication, because otherwise I would be reaching out to the distant cloud over the internet. And rather than that, I should use a fog node, which would help me control this domain, my slave domain. Sitting here, doing things here. This could be within one city. This could be from one particular office to a few acres of your other offices or your industrial domain. Yeah, limited to some cities and geographical zones. Infrastructure complexity is quite high, costly as well. Will take reasonable time for 5G to be deployed. In the meantime, can we have some ad hoc solution? Yes, we can have private 5G. It will give us 5G-like bandwidth within our private domain. Yeah. Let us take a look at private 5G. Important in areas where standard cellular 5G coverage is not possible. Or if in your city there is no 5G at all, why not have private 5G within your campus, within your industry? For internal communication through a middleware entity such as a fog node or multi-access edge computing. This middleware entity would provide us local resources, and 5G will provide us the low latency that we need. The other benefits of private 5G would be that the connectivity would be wireless. We'll have better control because no dependency on the network providers. We'll have our own private 5G and hence more security. And communication to the cloud or the backbone could be delay tolerant. Now, again, it depends on which scenarios. Some scenarios would be delay tolerant, the others won't be. This is how you could somehow establish your private 5G. You have your backhaul network, and you have your industrial network or your campus, whatever it is. Set up massive MIMO units plus the millimeter wave antennas plus beamforming and consolidate them through fog node for local processing and perform the 5G-like tactile internet for your industry. What kind of scenarios we can have in the case of private 5G-based industrial tactile IoT? Okay, we have rural area, we have industrial zones, and we have connectivity. Let's assume that in the metropolitan area we have 5G. Let's assume this thing. Okay, and in our industrial domain we have a weaker connectivity. This can be anything, for example 3G. In between we have 4G. So the connectivity is 5G, 4G, and now we need the private 5G here to have better bandwidth. Can we do that? Yes. And we'll achieve these things, which we have discussed already. Gbps instead of kbps. Now, the communication from here to the cloud would be through this backhaul, which could be delay tolerant. I need faster communication here, but sending the data later on to my server or to the cloud might be delay tolerant. That's fine. Are there any use cases of this kind of scenario? Yes, output of one 5G segment, input to another 5G segment. I have multiple 5G segments here. So I need this thing. Yeah. For example, let's say multiple sites of a company within an industrial zone. Online shopping, COVID-19, shopping from home, cannot go out, but I do want to look at the fabric texture. I can have a transceiver at my end, and then I can assess the texture of the fabric, the thickness or stuff like that for my online shopping. Much better online shopping experience. Also, you can have, as I mentioned, that you can have smell and taste sensors sent over the internet in tactile internet. So you can taste your food as well. Is it spicy or is it bad or this, whatever. I forgot the term we used to use for spicy food. I don't know. Something with M, I don't remember. Anyhow, company communication between site office and headquarters. Yep. And many other scenarios and many other use cases. Let us look at the second scenario. I don't have the 5G. I had 5G here in my metropolitan area, Seoul City, then in between, and then Suwon City. But now I don't have this thing, probably Yosu. So I can have a private 5G, no regular 5G at all, private 5G, and then internet cloud connectivity through the 4G. Use cases would be mostly based on the periodic delay tolerant internet updates. Haptics communication within the private 5G industrial site. CPS, for example, remote control of machines and devices. In the case of remote education, like in the work from home, today's era of, which is the result of the pandemic, we can have the hands-on experience, which we were lacking through tactile internet. For example, drawing, you need to help the pupil, for example, holding their hand, telling them how much force you have to put to do this thing. How are you going to make a stroke to do painting or stuff like that? Or any musical instrument, any artwork. You can remotely do this thing through tactile internet. And it is also possible that you already have 5G available, but still you create a private 5G for your industry. Why do you do that? For network slicing, for reliability, because you're not dependent on your service provider, and better security and privacy. My industrial data is huge. I don't want to make my data accessible to attacks or intruders. I would better prefer private 5G for my industry or my whatever it is. Use cases, those use cases that are more relevant to security and privacy. Cluster of hospitals. Cluster of hospitals here, they are all using private 5G, even though they do have public 5G. Cluster of industries for industrial data sensitivity. Audi, Ericsson, they do have private 5Gs. You can look at these. SK Telecom, the one and only, they do have private 5Gs for smart factory, for smart office, for Samsung, Cisco something, smart distribution of logistics, automation, robots. So you can see that some bigger industries, they're also looking at private 5G stuff. So in the era of 5G, we should not only focus on the 5G itself, but also on the use cases of 5G through private 5G. And I reckon that industrial domain, especially tactile internet, would be more relevant to this thing. QoE in tactile internet. Okay, we discussed this thing that QoS is important, but QoS has been important in the past as well. In the case of tactile internet, QoE would be even more important because users' actions are transmitted. Hence, this should be the user's satisfaction or user's acceptability of that service would be more important. There are different ways to assess quality of experience. I'm skipping it. I'm just running through this thing so that I can save some time. It's already overdue, I think. But you can go over these things through the resources I've shared. There are some papers mentioned at the end. One of the ways to assess QoE, quality of experience, or user satisfaction is through Net Promoter Score, NPS. It's on the scale of 0 to 10. Just like you give feedback that out of 10, I give you 7 marks. Out of 10, I give you 6 marks, 10 marks. 0 to 6, the group of these people are known as detractors. And this is negative feedback. 7 to 8 is considered neutral. People are known as passive. 9 to 10 is positive. People are known as promoters. Is there a way to incorporate NPS as users' feedback and based on that, create an NPS ratio? Through that NPS ratio, we can probably dynamically allocate resources. Can we do that? If we can do that, then we can dynamically adapt according to the perception of our users, the feedback of our users. Maybe we can incorporate the overall NPS that we have, the average of this thing, plus the NPS of a particular customer. And then based on that, calculate the NPS ratio. And based on these things, compute dynamic resource estimation, and then adapt accordingly. You can go over this paper for more technical details and algorithm, but I'll briefly run through this thing that in the beginning, no one has used a particular service, zero utilization of a particular service. I have a default Net Promoter Score. I have a default feedback of my service. And then the overall feedback is also the default one. Let's use them and create a base ratio so that we can get started. But if a service is used by some people, but a particular customer is using the service for the first time, then we don't have any historical record of customer feedback for that service. But we do have an overall feedback record of that service because some people have used that. Not this particular customer, but some have used that. So use default values for that customer, but use the overall NPS and then create a ratio. What if a particular customer has lower feedback than the other customers? Now this customer is returning customer, has used the service before. If the feedback is lower, do we need to enhance the resources for this customer so that this customer can catch up with the other ones and overall the feedback becomes better? And if it's already higher, then encourage that customer even more so that the customer's feedback stays positive. That would eventually give us better overall feedback. This is the main idea of this QoE dynamic evaluation. Let's look at this thing. Now, the customer is new. We have no record. Let's assume that the default NPS is 7.5 because out of these three ranges, 0 to 6, 7 to 8, 9 to 10, this 7 to 8 is the neutral one. This is the average one, kind of average one. The average is not 5. We are looking at the neutral group of NPS. This is based on the rules of NPS. So the average of 7 to 8 is 7.5. Let's take that and then overall NPS for different services here. Now this 7.5 is the NPS of my particular customer C that has just joined in and trying to look for a service. And my overall NPS for each service, service number 1, this is my overall NPS. Average of all customers, for example, 100 customers is 4. NPS for this service number 2 is 7. This number 4 is 9. Now, based on that, if we take a look at service number 1, the overall NPS is 4, which is quite low. And we assume that the average for this one is 7.5. So there is a lot of difference here, Let's have a greater NPS ratio so that the resources for this customer are increased, so that eventually this overall NPS gets better. Because if new customer gives us good feedback, then this 4 will become 5 and 6 and 7 and so on. Eventually we'll catch up. So that's the idea, the calculation of this ratio. If we have a returning customer, assume that this is assumption, okay? You can assume anything else. You can assume that the overall NPS is 5, okay? Overall NPS is 7. This is my overall NPS given by all of the customers that have used the service. The NPS of this particular customer that is in discussion right now for the first instance is 7. So the average is 7 and the feedback of this customer is 7 as well. Do we really need to increase the resources? Not really. The ratio should be 1, no increase here. Even though it is still useful to increase the resources. And we'll see that since I'm presenting just a part of this algorithm, that thing is also doable. We should do that so that this 7 becomes 8 out of 10 or 9 out of 10. We can improve this. In the case of instance number 2, this one, the feedback of customer C is 3, which is quite low. Our overall feedback is 7, lot of gap. The ratio comes through this formula, which is 2.33. Increase the resources with the ratio of 2.33 so that this customer gets better service and we can maintain or enhance this overall NPS. Same goes with the case when your customer's feedback is greater than your overall feedback. Assume that my overall feedback is 6. And in the case of, let's take an example of the first case, this one. Overall, it's 7, but my customer's feedback is, overall it's 6, but my customer's feedback is 7, which is better than the average of the other customers. Do I really need to increase the resources? Yes or no? Yes, because still the overall NPS is not that good. It's 6. It's in the range of detractors. So increase the resources, but not drastically, because we don't have a lot of resources. We're spending money on our resources. So just gradually increase the resources and catch up. 1.166. And based on these things, we can decide which middleware entity is more suitable for my tactile service. I'm using my tactile service within my domain, and I have multiple middleware entities, fog node 1, fog node 2, fog node 3, 4, 5. How much delay, minimum delay is incurred using this fog node? This is average. Should I give it a rank? Rank is 2. Is there a rank 1 fog node? Yes, this one. This one as well. Okay, so these 2 fog nodes are the best in terms of delay. How about jitter? Am I really worried about the jitter? If it's smelling something remotely, I don't care about the jitter. But if it's holding hand of my student for painting or drawing, then I do care about jitter. If it's remote surgery, then I do care about jitter. Okay, so which one is the best one? This one is the best one. 0.3 milliseconds, rank number 1. In the same way, you have latency, packet loss, and blocking probability of fog node. Fog node's capacity, and what is the probability that this fog node would decline your request because this fog node becomes overwhelmed with the requests. 15%, 12%, 11%. This one is the best one. You have the overall score. The fog having the minimum score is the best one. Maybe you can choose this one for your service. Go over these papers for further details. This one focuses on middleware entities and how we offload tasks, and what kind of middleware entity is more useful for a particular scenario. If you want to look at how middleware entities, especially fog node, would be useful in industrial IoT domain, what could be the use cases? Anything you can do in your PhD, this is the one. And if you want to focus on 5G tactile internet, then this is the thing. Web, multiple technologies integrate in the web, and current IoT era, we prepare for the tactile internet, also relevant for work from home. And tactile internet requires reliable communication as well as faster communication, which is provided by 5G. But 5G deployment is gradual. We need private 5G in the meantime, which would enable several use cases. QE is important. We can dynamically adjust our resources based on the feedback or QE. Thank you very much, everyone. Any questions?
Thank you very much, Professor Azam, for this very informative talk.
Welcome very much. I thought, because you mentioned that the duration of the lecture is
overall duration, 2.5 hours, so it is okay. We are not overdue. So I just felt that you are not looking at the clock, so just given you some that thing. So there is no worries on the timing.
Okay, if it was overwhelming, then I really apologize. But my intention was to give maximum information within that, since it was within the time, 2 hours or something. I thought
no, it was a very nice talk. It was a very nice talk.
Okay.
Not overwhelming in any way. So there is a question from Abbas. Please ask your question.
Thank you, Professor, for this is very informative session. I was thinking about 5G and fiber. Like obviously fiber will be more faster than 5G, right?
Yeah.
Then why currently we are not carrying remotely surgeries right now with fiber? Like we don't need 5G for this,
because 5G is wireless. You need wireless communication in most of the modern use cases. Having cables or having physical connectivity would be difficult. It would limit the mobility. That is why, since everything today, or most of the things today, we appreciate the wireless communication, wireless kind of stuff. Even the earphones right now they're wireless. So offloading tasks wirelessly, that's the future. We have to look at those use cases. In the case of fiber, you need to have physical connection, and that would also limit the distance, costly as well, and then many things would be difficult to handle at the machines and at the receiving end. That's why. But yes, there would be cases where fiber-based tactile internet would be possible.
Thank you. And one I had long ago, I watched a movie, video, there was a device for online shopping of perfumes, and they had this device for smelling, right?
Yeah.
It's not a question. It was QE, definitely in device there would be some chemicals, right, to produce that smell. So how this can be why that person has to buy maybe that particular perfume if he can like produce its own. Maybe it was that chemicals are more costly than perfume or something. Why?
No, not necessarily. It depends on, obviously, with the passage of time, you'll have better technologies. Right now, they're not widespread. Right now, we're just talking about how things can be made possible in the future. You can have these transceivers at both the ends to receive and transmit information. Same goes with the tasting of a food or anything, right? Smelling, tasting, all that stuff. So maybe today these devices are expensive. Tomorrow they won't be. But tomorrow they would be more relevant to us because we would be doing a lot of things remotely. Not necessarily because of the pandemic, but also this is how the life would be. The life has gone over the internet. So many things are through smartphones. So those chemicals are not really expensive, and it's possible to regenerate the same sense of smell, same sense of taste through your transceivers.
Thank you, Professor.
Welcome.
So are there any other questions?
Yes, Professor.
Okay, please ask.
Yeah, sure.
Yeah, Professor, I have a small doubt in that heterogeneous sensor. Like we have a lot of sensors will be there, like temperature sensor, grace sensor. My question is that what is the difference between the heterogeneous sensor and other sensors? Is there any difference, and sensing capacity? How much fast it will sense?
Yeah, so
Like
you
that?
have different sensors, right? You have different sensors. One sensor
Yes.
is, for example, for gas emission. Another sensor is for temperature. Another sensor is for humidity.
Yes,
Another
sir.
sensor is for, let's say, proximity or whatever it is. All these different sensors are heterogeneous. They are generating different data. Any difference among those sensors make them heterogeneous. The frequency of generating data, how many times a sensor sends signals, how many times per minute, let's say. And
Okay.
what is the size of that data? Sensor number one sends data once per minute, and the size is 1 kilobyte. Sensor number two sends 10 times per minute, and the size is 2 megabyte per each communication. All these different factors make them heterogeneous, make them different sensors. And to understand the heterogeneity or make sense of it or control that look, I don't need 10 times per minute data communication. Maybe I can minimize this thing because it's consuming more energy. Or can I switch to energy source? For example, during the daytime, it's solar energy. During the nighttime, it's maybe the battery, something else.
Yes, sir.
So you have the heterogeneity in terms of all these different factors, and you need a middleware entity to interoperate these sensors.
Yeah. Okay, Professor. Okay. Thank you.
Welcome.
So are there any other questions? So Professor Azam, I have one question. I do not really understand the philosophy of Net Promoter Score. I understand how it works, and you have explained from the examples that how it is working. So what is the user's feedback? Is it the feedback from the user for some particular service?
Yeah.
Right.
Yeah.
So if
NPS is just a generic feedback, just like when you purchase anything online, they ask you for feedback, right? Give us feedback out of 5, let's say 0 to 5, 4 stars, 3 stars, 5 stars, or out of 10. And some services would ask you to fine grain your feedback that on this point, give us feedback out of 10. On this point, give us feedback out of 10. For every single aspect of yours or of their service, they would ask you for feedback. Now, how do they use their feedback? Sorry, how do they use your feedback depends on them. There could be many different examples. One of those examples is make use of that feedback to enhance the service provisioning or service quality. And we saw in the examples, in the example that I showed, that you can use the feedback to enhance the resources in this particular example. Because we're talking about the resources. Right now, we are worried about the resources to minimize the jitter, to minimize the delay, so that the user experience becomes better. Because we're strictly talking about sending touch signals. I have a device here and I'm trying to control a machine from here. I'm moving my hand and the machine is controlled at the destination end. But my experience is not good. What should you do? Probably your middleware entity should reserve more resources for me. Or maybe on the site, there are multiple middleware entities. Probably I should choose a better one, switch me to a better one. This is possible through my feedback. The feedback could be in any form. There are many different forms. Maybe a voice command could be a feedback. But to make it comprehensible, I used Net Promoter Score.
So my concern is that if the quality of service in the future is dependent on the what kind of feedback I gave in the past. So for example, user 1 gave some good feedback, user 2 gave some bad feedback, then their quality of service will be different in the future. This, in my opinion, this goes against the philosophy of the fairness of resource allocation in different network scenarios. Is it so?
So why do you think this is against the fairness?
So in fairness,
are you comparing different customers?
Yes. So one customer, if he is very negative about some service, then based on this Net Promoter Score, his service may get worse or may be improved, depending on the baseline of that service. So
if you look at, okay. Yeah. If you look at the way we have done that, if you look at this, the resource increase is with a very small ratio. It's not 1, but it's not 2. It's not doubling. It's 1.16. So we're also making sure that the increase is not drastic. But this increase is also based on others' feedback as well. It's not just this person's feedback. We're not just incorporating NPS-C. We're not just incorporating the NPS, the Net Promoter Score of a particular customer C. We're also incorporating the overall NPS. If you look at this formula, you're always incorporating the overall NPS as well. Okay, and also there would be other ways to monitor the fairness. It's not that if someone is always saying that I'm not happy with this service and you keep on increasing the resources for them. You have to look at your resource pool as well. That is why you're always incorporating the overall feedback plus the customer's feedback, C and O. And obviously in the future, you can have more complicated systems where the aspect of fairness is more involved. So it's a good point, by the way. It's a good point.
All right, thank you very much. So maybe we can have more discussion on this offline.
Sure.
Yeah, so if there are no more questions from the students.
I have a question. Am I audible to you?
Sure.
Professor Azam?
Yes.
Professor Azam? Yeah. Actually, I have a doubt regarding IoT and IIoT.
Okay.
So in the slide number 18, I think.
Okay.
There's an image. There's a figure representing the Internet of Things
This
and
one?
yeah, exactly, industrial Internet of Things.
Okay.
So my first question is, because I am unaware of all those things in deep, because I do not belong to this sector of
Yeah.
research. That is why. First thing I want to know is like how effectively the IIT, I mean Internet of Things and
Yeah.
industrial Internet of Things are being executed worldwide.
How effectively? It's
How effectively?
most of the applications starting emerging in the second decade of the 21st century, 2010 onwards. And with the passage of time, things are being standardized. One of the important things is privacy and security. So the main challenge right now is privacy, security, and interoperability of devices. I'm purchasing devices from different vendors because I am worried about the technology as well as the cost effectivity. So these are the factors. With the passage of time, these things would be standardized. There are some service providers, you can look at their profiles and you'll see that some of them are giving you the service as you expect from them, while the others are not. So obviously, the standardization part takes time. And that is one of the reasons why I designed this talk by having an evolution kind of thing in the beginning, so that we realize that we always evolved while having confusions, while having one thing and requiring something else, instead of getting the something else first and then adopting accordingly or improving it accordingly. But rather we always realize that, oh, we are missing something, oh, we are missing something. So even today, if you ask me this question, I'll say that there are many service providers that are providing really good services, but IoT is not yet standardized.
Okay, so
there would be issues of fairness, just like Dr. Junaid mentioned. Would be issues of fairness, would be issues of privacy would be the prime thing, security, or too much of data communication. How would you make sure that unnecessary data is not communicated? How do you determine that something is unnecessary? You should have pre-processing on the ground locally through middleware.
okay, right. So yeah, this was this was first question, and I also have second question. If you don't mind, may I please
Sure. Yeah,
ask
why
you the
not?
second?
Yeah, you
Yeah,
can.
thank you.
As many as you
The
want.
second question. Yeah, the second question is related to the IIoT. In the slide number, I think it's slide number 17. Yeah, slide number 17. Where there's a schematic illustration of a smart factory of future.
Okay. This one?
Yeah, yeah.
Okay.
Yeah, thank you. Oh, I think, oh yeah, the slide number has been changed. I think, yeah. For the thing that we have been given and
Okay, no problem.
the thing that you are being shared, there's a difference. Okay, so this is the thing. In this smart factory, so this figure, this image, it depicts like this is the IIoT, right? Industrial Internet of Things, which means it's kind of smart factory thing, or it does like automation, right? Everything is automatic,
Yeah. Yeah.
or remote control. My question is, if we are able to control a factory or like industrial sector, can we control medical sector by using IoT? Let's say like like what's say Internet of Medical Things,
Yeah, sure, you can.
which means can we really operate very complicated surgeries? Can we withhold or we can proceed with some complicated surgeries by staying at remote, like from distance. Let's say the victim is in one country and the surgeon, the expert is in other country, and let's say they have to be operated. So can this be possible? This complicated surgery be possible by using the concept of smart technology, like here we have given smart factory, like likewise smart operating room or something, smart surgical room or something, by using 5G and all those things. Is that possible? This is my actually this is my real doubt. I've been thinking of it.
Okay, so I'll divide your question into two parts. Number one thing is, can we achieve smart healthcare or Internet of Medical Things? The answer is
Yeah,
yes.
exactly.
You can
Yes.
have sensors, you can have body area network, you can have devices within a hospital or even inside of your, let's say within your household. Okay, you can make use of those sensors and those devices to monitor someone or to provide adaptive as well as proactive healthcare. That's possible. That's the concept of smart healthcare. And I've also worked on time serving or opportunistic healthcare. You can look at that paper as well if you're interested. And that paper focuses on doctor or physician sitting at one location while the patient is in another continent, another country. That's possible. Yes. Now, the second part of your question, remote surgery while surgeon is sitting in one country while the patient is in another country. That's in most of the scenarios not possible. In most of the scenarios, because I mentioned in this talk that some of the tactile internet applications require less than 1 millisecond delay, which means that, and that would be more applicable in the case of remote surgery. A surgeon performing surgery from here, moving his hands, her hands here, and the operation is performed at the destination end. A very minor mistake can be disastrous. You need to have, I don't know the extreme word for I don't know, hyper improvement or, you know, extreme accuracy. Yeah, we call it ultra low latency, reliable connectivity, reliable communication, ULLRC. So ULLRC is the main theme or attribute of tactile internet, especially in the sense of remote surgery. Remote surgery would be possible within a city, even restricted to much smaller geoscale, but not one country to another country, unless you're sitting at the boundary of one country and the surgeon is sitting at the boundary of another country. That's possible, but otherwise, no. It's not possible. But remote healthcare through tactile internet is possible. We talked about some use cases, right? And if you want to look at more use cases, then go over the opportunistic healthcare paper that maybe you can find on my website or online.
Yeah, sure.
It talks about this thing.
I would go through it. I'll really go through it. It's really interesting. As you speak of it, it seems really interesting. So I can conclude that when it comes to medical field, field, so we do have some limitations, right? When we are considering remote surgeries or something. So as you said, delays cannot be tolerated, even minute delays or inaccuracy or something. Okay. Yeah. That
sure.
was my real question.
Definitely. Yeah.
Thank you, Professor.
Welcome.
Are there any other questions? So it seems that there are no further questions from the students. So then I will thank you, Professor Azam, for your time and very motivating and informative talk. And the presentation was very well made, and also you explained everything in very well detail.
Okay, my pleasure. I'm happy if it was useful. I'm really happy, and I'll be available for any further communication, anything you want to ask, any student, anyone, our professors. No hunger question here.
Yeah, it seems that there are no questions from the Korean students.
Okay.
Anyways, I thank you very much for your time, and it was really nice attending your talk and seeing you here online. So looking forward to meeting you in person sometime. And also I'm thankful to all the students who attended this talk, and see you all the students next week. Thank you very much.
I'm also thankful to everyone, to you for arranging this thing, and Kyung Hee University, as well as all the participants. I don't know if there are professors, other people from other domains, students, everyone. Thanks very much for having me here. Thank you so much for your participation. Take care.
Take care. Bye-bye.
Bye.